Hi, everybody. So in this video, we are going to look at what I like to call some weird equations. They kind of deviate and look a little bit different than our one-step and two-step equations that we've been looking at. So an equation like this, 4x plus 5 equals 21, this is what we would kind of classify as like a more normal equation. We actually call these kind of equations that are set up like this, where it is a coefficient, a variable, plus or minus some sort of constant and have it equal to something. We actually call these linear equations. When we start working on graphing in our geometry unit, these kind of equations, when we learn how to graph them, they're going to actually be straight lines. So that's kind of where this word linear, you can kind of see it's like a fancy way of saying line, comes from. So these are kind of what's classified as more normal equations. There's also equations like that we've been doing, like x minus 6 equals 10, or 5 minus 2x equals 13. These are just some more examples of what we would call these like normal or linear equations, okay? So the equations that we're gonna look at today, we're going to end up solving them using the same three-step process. However, they're going to look a little different in the way that they're formatted. So the first equation we're going to look at, we're actually going to need to use the distributive property to solve it. So here is an example of an equation where we need to use the distributive property. So let's say we have the equation 1/4 times the group 12x plus 20, and we'll set this equal to 95. So if you need to take a moment and pause the video to write this down, you can. But this is an example of an equation. We have two expressions that are equal to each other, but if we follow our three-step process, we need to combine our like terms, then get rid of our constant, then get rid of our coefficient. In this case, you can see we have a coefficient 12, we have a constant of 20. However, this entire group, this entire expression right here is multiplied by this 1/4. So before we can go about solving, we need to use the distributive property to kind of simplify our equation. So that way we can make sure, you know, does this coefficient change? Like what is our coefficient? What is our constant? How does this distributive property change that? So we're going to distribute the 1/4 to each term of the group by multiplying. So we are going to do 1/4 times 12x, and I'm just going to put 12 like this, 12 over 1, because we're going to multiply some fractions here, and a whole number, we can rewrite it as a fraction over 1, plus 1/4 times, I'm also going to convert 20 into a fraction, which would just be 20 over 1, and we're going to set this equal to 95. So if we go about doing our distributing, we're going to multiply, let's look at this first term. We're going to multiply 1 times 12, which is 12, 4 times 1, which is 4, and we're going to keep the x attached to it. So we have 12 over 4 equals x. Now, since I know the fraction bar means division, 12 divided by 4, take a moment. What is that? Should be 3. So 1/4 times 12x is the same thing as 3x. We're taking a fourth of 12, meaning we're dividing it into 4 groups. There's 3 in each group, okay? So this particular term, when we just use the distributive property, simplifies to 3x, okay? Let's see what this one is. 1 times 20 is 20. 4 times 1 is 4. I don't have any variable, so 20 divided by 4 can be simplified to 5. Okay, so when we multiply 1/4 times 12, we get 3. When we multiply 1/4 times 20, that simplifies to 5. So the equation we're really working with now is 3x plus 5 equals 95. And this looks way more like one of these normal equations, okay? So now we're going to use our three-step process. We don't have any like terms to combine. So I'm going to get rid of my constant. I'm going to do the opposite kind of math. I'm going to subtract 5. So I'm using the subtraction property of equality to figure this out. So I'm going to subtract 5. and I have 3x equals 90. And since I'm multiplying 3 times x, I need to figure out what times 3 makes 90. Some of us may know it off the top of our head, but if we don't, we can use that division property of equality. And so x is going to be equal to, move my paper down, x is going to be equal to 30. So this is a case where we use the distributive property to set up or rearrange our kind of weird equation with the distributive property to make it into a more normal equation. That's why we learned the distributive property first before we started doing any of this stuff with solving equations, because it really helps us set up a simpler equation to solve. This is much simpler than trying to think about all this going on here. Okay, so we're going to look at an example. We're going to look at an example now where knowing that a letter on its own, a variable on its own, is the same thing as 1 times that variable. So what I mean by that is, let's say I have the variable m, okay? M by itself is the same thing as 1m, okay? And in a similar way, sorry, there we go. Negative m is the same thing as -1 times m. Okay, so pay attention to kind of how the variable looks on its own with the negative sign. That means we're multiplying it times -1. Without the negative sign, that means we're just multiplying it by 1. Okay, because let's say we have the example 15 minus m equals 41. There we go. So I can't rearrange this to be m minus 15 because that commutative property doesn't work. Like 15 minus 1 is not the same thing as 1 minus 15. Did I say the same thing twice? 15 minus 1 is not the same thing as 1 minus 15. 1 would be 14 and then 1 would be a -14. So we need to think about this particular equation. We're going to use the 3-step process, combine our like terms, which we don't have. We're going to get rid of our constant, but our constant and the way this equation is set up is right here. Okay, another way to think about this is 15 minus -1 or minus 1m. Okay, the coefficient in this problem is 1 or -1. You could think about it that way. Okay, this 15 is a positive. If it helps you to write a little plus sign next to it so you remember it's positive, you can. So if I get rid of the constant, I'm going to do the opposite kind of math. This 15 is a positive, so I'm going to subtract this 15 away from both sides. And what I'm left with, I'm going to write it over here. I'm going to kind of go up here. What I'm left with is -1m equals 41 minus 15 is going to be 26. So I'm left with -1m equals 26. So I'm not going to leave my answer as like a -m. I'm now going to use, so I use the subtraction property of equality right here. I'm now going to use the division property of equality, but in this case, I'm going to divide by -1. I'm going to divide by -1. So m is going to be equal to 26 divided by 1 is 26, but it's a negative, so this is going to be -26. Okay, and if I go back and kind of look at this problem, 15 minus something is going to get me 41, which is bigger than 15. And the only time that really works is when we subtract a negative. So 15 minus a -26 is the same thing as 15 plus 26, which is where this positive 41 comes from. Okay, so don't forget, if a variable is on its own, that means that there you can put a coefficient of 1 in front of it. And if there's a subtraction sign, we want to think about it as like a -1. There's an addition sign, we could think about it as like a +1. Okay, so there is a question on your homework that's very, very similar to this. So I encourage you when you're looking at your homework, and I can even tell you right now, it's number 6 on your homework. Okay, come back and look at this particular problem. And there are some problems like this one that we just did. This one is very similar to number 5 on your homework. So if you want to use these 2 examples to help you with some of your homework problems, they're a really good example. Okay, so these are two examples of like some weirder equations where they're not quite set up in the same way that we've been seeing before. So use these to kind of help you with your homework.